Hi students, very good morning. Today in this lecture we are going to deal the factors on which the rate of reaction depends. So ROR. So the speed of the reaction, it depends upon what factors. Okay. Entirely this video is dedicated to the factors on which the rate of reaction is getting depended. So first one is nature of the reactant. So you are taking, first of all you should be having reactants, right, to undergo reaction. So you are having reactant. If the reactant is ionic compound, okay, or if the reactant is covalent compound, then which will be having the more rate of reaction. So if that is ionic compound, the rate of the reaction will be very high when compared to the reaction which is having covalent bond. So if we ask the rate of the reaction among ionic compounds and the covalent compounds, which will be having the highest rate, means ionic compounds will be having the highest rate of reaction when compared to the covalent compounds. Why? Why means in ionic compounds there will be no breaking of bonds or no formation of the bonds between the ions. They will be just beside. In the first year chemical bonding already you have learned that ionic bond is a non-directional bond and there will be no bridge between the two ions. Just they will be present beside. That is what it is called as lattice. Okay. So ions will be very closer together due to the electrostatic force of attraction. There is no formation of the bond or breakage of the bond. So these reactions, ionic reactions, will be very faster, right, compared to the covalent reactions. So in covalent reactions, suppose you are having N2 molecule as well as 3H2, it is forming 2NH3. See, among nitrogen you are having 3 bonds, among hydrogens for each H2 molecule you are having 1 bond. As you are having 3H2 molecules, you will be having 3 bonds, and 2NH3 means here the breakage of bonds is done. Okay, and here the formation of the bond should be formed. So it takes a lot of time. So this, which one will be very faster means the ionic reactions will be very faster when compared to the covalent bonds. So if you have any competition with respect to covalent compounds, and the covalent compounds with less number of covalent bonds will be very faster when compared to the reactions of the covalent compounds which is having more number of bonds. You will be learning with respect to that one also. Next, among the covalent reactions, if you go for the homogeneous reactions as well as the heterogeneous reactions, homogeneous reactions will be very faster. Okay, means those should be having same state. Reactants, if both are gaseous, see here you are having both are gaseous. If one is solid and one is liquid, that will be very slower. If one is gas, other is the solid, that will be slower. If one is liquid, other is gas, that will be slower. Okay, and when there are homogeneous reactants, the rate of the reaction will be very higher. When the heterogeneous reactants are there, the rate of the reaction will be lower. Okay, ionic reactions will be having more rate of reaction compared to the covalent compounds. Among covalent compounds, the covalent compounds which are having less number of covalent bonds will be having more rate of reaction when compared to the covalent compounds having the more number of bonds. Among homogeneous and heterogeneous, the rate of the reaction will be very higher for the homogeneous reactants when compared to the heterogeneous reactants. So simply we can say that rate of reaction is directly proportional to the stability of the product. If product is formed more fastly and there is more stability for the product, then automatically reactants will dissociate and they will form product. Assume that there is a reactant and there is a product. Reactant is getting converted into product. If product is more stable, means what happens to the reactants? Reactants immediately tries to get converted into the product. Means the reactant is undergoing reaction to convert into product so that to attain stability. So this type of reactions are very faster. Okay, so the rate of the reaction, it is directly proportional to the stability of the product and inversely proportional to the stability of the reactant. If reactant is more stable, suppose among these two, if this is more stable, this will not form, product is not formed. So what happens? That retains in the reactant stage itself, so that the reaction will not occur. Then you can't calculate the speed of the reaction, means you can't calculate the rate of the reaction. So the rate of the reaction is directly proportional to the stability of product and inversely proportional to the stability of the reactant. Suppose let us take one example like acetic acid. So it forms what? CH3COO minus plus H plus. This is formic acid, HCOOH. It undergoes dissociation and it forms HCOO minus plus H plus. See, CH3COO minus. See, among these two, that is CH3COO minus and HCOO minus, which is more stable? See, go for the first year. Based on the what? Inductive effect. You calculate. Based on the plus I effect, this one is highly unstable. This one is more stable. Okay. See, CH3 is a donor group. Basically, it is having electrons. It is also donating electrons. So that more electron load will be present on this molecule. So that it easily undergoes reaction. Here, this is donating. This is not donating. This is not accepting. Okay, it is neutral. So what happens when compared to this one is less donating. Okay, so that these electrons will be highly reactive. This one is low reactive. So this is stable. Means when product is more stable, this one will undergo easy reaction. Here also, product is highly unstable. Means reactant is more stable. So this one will not be formed easily. Among these two, which is stable, HCOO minus is more stable. So the rate of reaction of formic acid is greater or faster compared to the rate of reaction of acetic acid. Okay. Next condition is physical state of the reactant. Gases, liquids, solids. So the rate of the reaction will be very faster. See, gases will be having high energy. They will be giving more number of collisions so that it can easily form products. So gases state will be having more collisions. So this one will undergo very fast reaction when compared to the liquid, and when compared to solids, liquids will undergo very faster reactions. Right? And going for the surface area of the reactant. So rate of reaction is directly proportional to the surface area. This is very lively example. Take a cup with milk. So, option 1, you take some crystals of sugar. Option 2, you take some powder of, here also 10 grams of sugar in terms of crystals. Here also 10 grams of sugar in terms of powder. Which one among these two, which one will easily dissolve in this milk? Means we can say that powder will easily dissolve. Why? Means more surface area is getting exposed to the milk, so that easily it can dissolve. Right? Getting the students? More is the surface area exposed of the reactants, more will be the rate of reaction. So rate of reaction is directly proportional to the surface area. In example, rate of reaction with respect to sugar crystals is more with respect to sugar crystals. In that, sugar powder will be having more rate of reaction compared to that of the sugar, whatever that is present in the cube form. Okay. And if you go for one more content like intensity of light. Okay. Some reactions are photosensitive, means they will occur by the appearance of the light. Suppose if you take H2 as well as Cl2, those two will not react. How much amount they may be, they will not react. Whenever if you pass light, then only that reaction will occur and it results in the formation of HCl. See, again I am telling, H2 and Cl2 if you take, okay, if there is no light, there is no formation of HCl. The formation of HCl will be present only in the presence of the light. So these reactions which occur in the presence of the light, those are called as photosensitive or light sensitive or photochemical reactions. Okay. See, H2 you take some 100 tons, chlorine you take some 100 tons. Those two will not react in the absence of light. If light is present, then these two will react. Okay. Then only there will be formation of products. Means the formation of the product is depending upon H2 or Cl2. No, it is not at all depending upon the amount of H2 or amount of Cl2. It is depending upon only on the light. So these type of reactions are called as photosensitive reactions or light reactions or photochemical reactions. So more is the intensity of the light, more will be the number of photons, and more will be the rate of the reactions. So more the number of lights you see means more the number of lines. You are not increasing the frequency of the light, you are increasing the intensity, means the number of waves you are increasing. So 10 waves, 20 waves, 30 waves, you are increasing the number of waves, not the intensity, right? So intensity of the light if you increase, the number of photons will be increased, so that the rate of the reaction increases. Next condition is catalyst. See, catalyst is that substance which speeds up or slows down the rate of the reaction. Okay, catalyst can increase the speed of the reaction. If it increases the speed of the reaction, means rate of reaction, if it is increased, then that is called as positive catalyst. If it decreases the rate of the reaction, then that is called as negative catalyst. Okay. How it increases the rate of the reaction or how it decreases. Generally, we will not be dealing with respect to this one. Negative we will not read. Why means we need the reaction to occur very fastly. No need of slow. Okay. There are some catalysts which are called as negative catalyst. If you use that, the rate of the reaction will be slowed down. Generally, we will be not dealing with respect to this one. We will be dealing only with respect to this one. So we are using a catalyst which speeds up the rate of the reaction. How it speeds up the reaction? Means it sets up an alternate path from reactants to product by lowering the activation energy. So this catalyst, what it does? It takes the reaction from one part to other part. So I will show you in terms of graph. So here you are having reactant without catalyst, means this brown color line. So it should come up to this level of energy. Here energy is plotted. Reactant's energy should go on increasing, and it should come to this point of energy. Then only it gets converted into the product. So you are getting the product. Okay. This is the path of the reaction which occurs without catalyst. and this is the energy of the reactants. The difference between the energy of the reactants and the highest amount of energy for a reaction to occur, this energy it is called as ET energy. Okay, this energy it is called as ET energy, that is called as threshold energy. Getting me? So this is the reaction path which is occurring without the catalyst. So what is this EA? Means energy of the reactants, energy of threshold. It is called as energy, activation energy. So this energy minus here energy of reactants. This is the energy of the reactants. This is the threshold energy. This difference, threshold energy minus energy of the reactants, that gives the activation energy. Okay. So this is the path which occurs without catalyst. And if you add catalyst, what happens? This reactant, this energy, it moves in this path. Okay, it is getting the product. So here threshold energy is this much only. Means this is the threshold energy. Means what is this happening? If we add catalyst, okay, the threshold energy level has been decreased by changing the path. So this is the original path without the catalyst, and this is the path with the catalyst. So without catalyst it is following this, without catalyst it is following this path. This path has been changed by lowering the activation energy. In this way the reaction will be occurring. It results in the formation of the product. So example, if you take SO2 plus O2, it gives rise to SO3 in the presence of catalyst NO. Generally the rate of the reaction, it is represented here in the form of NO. It is not represented with this one. See, you remember this. These are the major limitations. Okay, you should remember. There are some reactions which doesn't depend upon the reactants. There are some reactions which, in simple way I will tell, there are some reaction which depends upon the rate of the reaction depends upon the rate, concentration of the reactants. There are some reactions where the rate of the reaction depends upon the products. There are some reactions where the rate of reaction depends upon the catalyst. So the rate of the reaction, this is generally it is calculated experimentally. Okay, it is not calculated theoretically or paperwork. This is experimentally purely. So in this they have found that the rate of the reaction is depending upon the NO, that is catalyst. It is not depending upon the reactants, or it is not depending upon the products. So the rate of the reaction can be either it may be depending upon the reactants, products or catalyst. Okay, but not on the intermediates. Okay, we will learn at the last. It may depend upon the reactants, it may depend upon the products. That is what? Rate of reaction. Rate of reaction may depend upon the reactants. It may depend upon the products, or it may depend upon the catalyst, but not upon the intermediates, whatever that are formed in the formation of the product. Right. Next condition is temperature. Generally, the rate of reaction increases on increasing the temperature. Generally. Okay, there are some conditions where it will be decreased. Generally 99%. Generally, rate of the reaction increases on increasing temperature. So on 10 degrees raise in temperature, rate of reaction increases to 2 to 3 times. Okay. Again, you remember this. Generally, on increasing temperature, the rate of the reaction will be increased. On increasing 10 degrees raise in temperature, rate of reaction increases to double. For every 10 degrees raise in temperature, the rate of the reaction becomes double. In some cases, it will be tripled also. Okay. And you remember some points, the concentration of the reactants. Generally, ROR, that is rate of reaction increases on increasing the concentration of the reaction. This is also 99%. Generally, the rate of reaction increases on increasing the concentration of the reactants. Rate of reaction may also decrease on increasing the concentration of the reactants. In some cases, the rate of the reaction is unaffected, means no effect of the concentration of the reactants on the rate of the reaction. In some cases, rate of reaction may also depend upon the product's concentration. That is what I have mentioned in the previous page. So what I have said, rate of the reaction may depend upon the product's concentration, may depend upon the concentration of the reactant. Sometimes it is unaffected, means it may depend upon the catalyst. Rate of reaction may depend on one or all or none of the reactants. Sometimes there may be 4 reactants. It may depend on 1 reactant, or it may depend upon 2 reactants, 3 reactants. Sometimes it will not at all depend. So you have seen the above reaction where the catalyst reaction. It is depending only upon the concentration of the catalyst, not upon the concentration of the reactant. So rate of reaction may depend upon the concentration of the reactant. It may depend upon the concentration of the product. It may depend upon the concentration of the catalyst, or it may not at all depend upon the concentration of the reactants. Okay. Generally, concentration increases, the rate of reaction should increase. But there are some cases where the rate of reaction also decreases with increase in the concentration of the reactants. This is what for today's students. Go through all the theoretical concept here. get thorough idea and you practice all the contents whatever that are present in your book. Have a nice day. Bye bye.